Good morning. My name is Tang Qianqiao from the Department of Physiology. First of all, I would like to thank the organizers for giving me this opportunity to share some of my research data with you. So today, my topic will be influence of CD127 ligand signaling on myelopoiesis during inflammations. So this term may sound a little bit alien to most of you, but if I change, let's say if I change the topics to how the influence of crime rates heighten the police force, maybe it will make it a little bit more understandable to you. So first of all, I'm going to give a very brief introduction of our hematopoietic system. So just imagine our human body as a society. So each cell is doing its own job. These cells are highly differentiated. So our blood cells cannot become brain cells, and the liver cells cannot become muscle cells. However, we have a small group of cells that is called the hematopoietic stem cells, which stay in the bone marrow, so they can give rise to all kinds of cells in our bodies. I'm particularly interested in the blood cells because a huge part of our blood cells are actually immune cells. And these immune cells protect our bodies against the invasions of pathogens like bacteria and viruses. So first of all, I would like to tell you about these cells. So neutrophils and macrophages, they belong to the innate immunities. So these cells are the first line of defense of our bodies. So they are like the policemen in the society. So when there is a pathogen invasion, the macrophage and neutrophil will rush forward and try to engulf the bacteria. The problem with macrophages and neutrophils is that they do not develop memories. So they cannot recognize the bad guys when we have the same infection again. So now we need a lawyer. That is the dendritic cells. Dendritic cells will capture the antigens from the bacteria and virus, and then they are going to present these antigens to the B cells and the T cells. And the B cells can develop memories against the pathogens, and they are going to make some mass destruction weapons like the antibodies. So next time the same pathogen came in, they can quickly wipe out the bacteria and the virus. However, there are times that we don't have enough police force. So we don't have enough neutrophils and macrophages in the first place to help us to maintain the infection at a low level. So what can we do? So T cells have been known to maintain myelopoiesis in the literature. So if you remove T cells from the system, actually the myeloid cells, the number of myeloid cells will be reduced. How can T cells do this? So first of all, T cells can do it by soluble factors. So they give some growth factors to the stem cells. And the other way is they can express some surface markers. So this surface marker can cross-link another markers on the stem cells and tell the stem cells, hey, please, I need more police force, please make some. So what are these surface markers? So they function as a crime report of our legal system. So one of the molecules I'm interested in is called CD127. CD127 is a molecule expressed only when there is an emergency. So when there is an infection, they will be induced on the T cells. So it's like alarming signals to the hematopoietic system. CD127 have been known to activate the T cell and induce proliferation of the T cells. And myeloid cells, including macrophages, neutrophils, and dendritic cells. The ligand of CD127 can also induce the activations of the myeloid cells. More recently, our lab find that actually CD127 ligand is also expressed on stem cells. So we wonder, can this CD127 ligand also induce the stem cells? Can they influence the decision making of the stem cells to tell them to make more myeloid cells? So this is the methodology of my system. So in immunology study, we had the knockout mice is a very commonly used strain. So we had the white-type mice and we had the CD127 knockout mice. So in these knockout mice, there is no alarming signal when there is an infection going on. And next, I'm going to create a small crime scene. That is the infections in the mice. So what I'm going to look for is the CD127 signal in the bone marrows. Is there an upregulation of this activation signal in the bone marrows? I'm going to do this by immunohistochemistry. And next, sorry for this typo. And next, I'm going to look for whether this CD127 signal is expressed by the T cells. And of course, if there is enhanced of CD127 signals, I need to correlate them to the level of myelopoiesis. And I'm going to do this by flow cytometry. Flow cytometry is like an ID scanner. So different immune cells express different surface markers. So by using flow cytometry, I can identify what these cells actually are. So first of all, let's look at the CD127 level. With the help of our collaborators from departments of microbiology, I managed to get some bone marrows of mice infected with different pathogens, like influenza, BCGs, and Bordetella pertussis. And these are bone marrow sections of the mice. The blue staining are the nucleus, and the brown stainings are the CD127 positive cells. So as you can see in the naive mice, we have very little or hardly no signals in the naive mice. So these mice are healthy, they are not infected. But if the mice become infected with pathogens, you start to see an increase of these CD127 positive signals. So meaning that we have more crime reports in the headquarters of our hematopoietic systems. The question is, are these T cells? Just by immunohistochemistry, I cannot tell. So how to identify these cells? Because of the limitation of a lab, I cannot do all three models at one time. So I decided to do a simpler models. That is the acute peritonitis. So I used the very common bacteria that's called the E. coli, and I had two strains of mice, the wild type and the knockout. So on day 0, I inject the E. coli into the intraperitoneal, that is into the belly of the mice. And the mice start to develop the peritonitis, so they are very sick. And then on day 2, I sacrifice the mice, and I look at the CD127 positive cells in the bone marrows to see whether they are T cells. And next, I'm going to look at the percentage of CD11B cells. So what is CD11B? CD11B is a common marker for the myeloid cells. So all macrophages, neutrophils, and dendritic cells express CD11C. So by looking at this marker, I know the level of myelopoiesis. So this is the flow cytometry. To know whether the cells are T cells, I need to look for the marker called CD3. So this is CD3 and this is CD127, and this is the cell of interest. So in the naive mice, which are mice not infected with pathogens, we have very few cells of the CD3 and CD127. So meaning that there are no activated T cells in the bone marrows. But once they get infected with E. coli, we see an upregulation of the populations from 0.07 to 0.92. You may say this is too small, but actually the T cells are indeed a very small population in the bone marrows, but they are doing big jobs over there. Of course, I need to correlate this to the myelopoiesis. So how about the CD11B populations under inflammatory state? So we have the CD11B here, which is similar between wild type and knockout mice. However, once the mice become infected with E. coli, we had upregulations of CD11B cells in the wild type mice compared to the knockout mice. So now we have positive correlations. We have more crime reports, and then we have more police force in the bone marrows. And how about whether the cells are really proliferating? So if in order to know that the cells are really proliferating, I give the mice an DNA analog, which is called the BRDU. So whatever cells that is proliferating, they will uptake the BRDUs, and then I stain the BRDU, and I know that is indeed the cells are proliferating in the wild type mice. So again, please look at this population, is the cell of interest. The cells are positive for BRDU, the DNA analogs, and also the CD11Bs. So now we know that if you compare wild type and knockout mice, you can see that the wild type had an enhance of the CD11B positive and BRDU positive cells, meaning that these cells are proliferating. And these are the situation of acute inflammation. And how about chronic inflammations? So aging is actually a process of chronic inflammation, and I'm really interested into it. Because in aging, I think there are more pro-inflammatory cytokines ongoing in the periphery. And also the T cell, they may express more CD127 on the surface. So aging actually is an imbalance of hematopoiesis. So if the T cells are really expressing more pro-inflammatory cytokines and also the CD127, we will have more myeloid cells, but fewer lymphoid cells. That is the B cell and the T cells. Then we will develop an imbalance between innate immunities and adaptive immunities. So again, when I look at the myeloid cells, the bone marrow of the young and the aged animals, what I find is a very similar situations to our acute inflammations. So I have mice that are 3 months old, wild type mice 3 months old, and wild type mice that are 8 months old. So the 8 months old wild type mice actually have a higher CD11B positive populations than those 3 months old. However, in the knockout, you don't see this change at all. So meaning that in the chronic inflammation, we see the same effect that actually the CD127 induce a higher percentage of myelopoiesis. So to conclude my work, so what you have seen is that the CD127 on the T cells actually is induced during the inflammations, both in acute or chronic situations. And then they can bind to the hematopoietic stem cells and induce a proliferation of the myeloid cells. with bioengineering to try to immobilize the CD127 protein onto a nanoparticles. So by injecting the nanoparticles into the mice, hopefully we can promote the myelopoiesis during the infections, and hopefully can rescue the mice from the infection state. And this is the end of my presentation. Thank you for your attention.